Europe just committed €500,000 to Flatpak, a Linux software distribution system, as part of its new sovereign AI strategy. On the surface, it sounds like a smart move: fund open source, build local tech. But dig a little deeper, and you'll find this isn't just a missed opportunity. It's a strategic misfire that could actually slow European innovation and cost taxpayers far more in the long run. We're talking about a multi-million euro effort to build an independent AI ecosystem. Yet this specific investment feels like fighting the last war. The real battle isn't about packaging apps for desktop Linux. It's about controlling the underlying AI models, the compute, and the talent. This isn't just about what they are funding, but what they aren't, and why focusing on this niche could cripple a much larger ambition by 2026. Stick with me, because the biggest danger isn't what you think, and the final piece of this puzzle reveals why this seemingly small investment could undermine Europe's entire AI future. The European Commission is funding an initiative with €500,000 to support sovereign tech development, specifically around Flatpak, a Linux application sandboxing and distribution framework. On the surface, it sounds like a sensible move, fostering local control over critical infrastructure. But dig a little deeper, and this seemingly innocuous investment reveals a strategic blind spot that could cost European taxpayers millions and widen the innovation gap. This week, we're unpacking why channeling these funds into a niche packaging format, rather than into foundational AI research or compute infrastructure, represents a critical misallocation of resources. When you look at what countries like the UAE are doing, like their recent $100 million investment into AI startups and talent through the AI House initiative, Europe's Flatpak focus feels like bringing a knife to an LLM fight. We'll explore why this emphasis on packaging, rather than processing, sets Europe up for a costly dependency by 2026. This isn't about Flatpak's utility. It's about strategic timing and what truly defines digital sovereignty in the age of AI. The real question is, how does Flatpak, a Linux software distribution system, become a cornerstone of sovereign AI? With €500,000, when the core problem of AI isn't distribution, but computation and massive data infrastructure. Let's unpack this sovereign AI idea. Countries, especially within the European Union, are understandably keen to avoid being entirely dependent on US or Chinese tech giants like Google's DeepMind or Tencent's AI labs for critical AI infrastructure. It's a multifaceted play. A national security imperative to control sensitive algorithms, a data privacy imperative to comply with regulations like GDPR, and an economic play to foster domestic innovation and retain a share of the burgeoning €1.5 trillion global AI market. The goal is to build AI capabilities within their own borders, using their own companies like France's Mistral AI or Germany's Aleph Alpha on their own terms. So, enter NLNet, a Dutch foundation, acting through its NGI Zero initiative, which champions open internet technologies. Back on April 26, 2024, they announced a significant grant of €500,000, specifically earmarked for Flatpak development. The stated aim? To empower European tech sovereignty by developing AI or ML services within robust, secure, and decentralized containers on desktop Linux systems. On paper, Flatpak does offer simplified software deployment and strong isolation, which sounds appealing for government initiatives that prioritize security and control. Imagine a scenario where the German Federal Office for Information Security, BSI, wants to deploy a confidential AI model for internal threat detection. Flatpak could theoretically containerize it, making it easier to manage updates and ensure data isolation on individual machines, preventing conflicts with other software. But this entire premise sidesteps the gargantuan challenge of building actual AI infrastructure, including vast GPU farms and petabytes of training data. This brings us to Flatpak's secret double life: its power and its problem. Flatpak, a packaging system heavily funded and promoted across Europe, currently hosts over 2,000 applications in its primary FlatHub repository, including popular tools like GIMP and Firefox. However, its very architecture, while excellent for desktop applications, creates a fundamental bottleneck for advanced AI. At its core, Flatpak is a universal Linux application packaging system. Initiated by Red Hat engineer Alexander Larson in 2015, it bundles an app and all its dependencies into a sandboxed container, aiming for reproducible builds and easy deployment across diverse Linux distributions such as Ubuntu 22.04 LTS, Fedora Workstation, or Arch Linux. This App Store model offers strong isolation for security and stability, meaning one application, like the VLC media player, can't easily interfere with another or the core operating system. This robust sandboxing is fantastic for consumer-facing desktop software. Yet, this strength becomes a significant hurdle for AI. Flatpak's inherent sandboxing, while ideal for isolating a word processor like LibreOffice Writer, inherently restricts deep, low-latency access to underlying system resources. The system relies on portals, a method for applications to interact with the host system, requiring explicit user permissions for actions such as printing, accessing files outside the sandbox, or leveraging specific hardware like a connected webcam or a GPU. It's akin to having a highly efficient, but permission-bound, security guard at every system interaction point. This model, a testament to security for consumer desktop applications, begins to buckle under the insatiable, low-level resource demands of modern AI models, particularly those requiring direct access to GPUs or large datasets stored outside the sandbox. The critical question then becomes, how can a system engineered for stringent sandboxing and explicit, granular permissions effectively accommodate the ravenous and often direct hardware access requirements of cutting-edge AI? But here's the kicker. For all its benefits, Flatpak is fundamentally at odds with the demands of modern AI, especially when it comes to harnessing the power of GPUs. The critical flaw for AI comes down to low-latency access to hardware. High-performance AI and machine learning workloads, from training large language models to running complex inference, rely heavily on direct, unencumbered access to GPU hardware and specific drivers like NVIDIA's CUDA, AMD's ROCm, or even OpenCL. This isn't a nice-to-have, it's a foundational requirement. The problem is, Flatpak sandboxing, while excellent for security and dependency management in desktop apps, creates a major challenge here. It abstracts away or restricts that direct access to kernel modules, specific driver versions, and shared libraries that are absolutely essential for GPU acceleration. Think of it like trying to drive a Formula One car through a series of speed bumps. The engine is powerful, but it can't perform. Current workarounds often involve shipping entire GPU driver stacks within the Flatpak runtime, which leads to massive bloat, potential version mismatches, and, critically, reduced performance or instability. It's a hack, not a solution. This complexity is compounded by the rapid evolution of GPU drivers from NVIDIA, AMD, and Intel. Keeping Flatpak runtimes up to date with the bleeding edge of CUDA 12.4, for example, or the latest ROCm version, becomes a perpetual game of catch-up. NVIDIA alone releases new drivers every few weeks, each often with performance optimizations crucial for the newest AI models. This constant churn makes it incredibly difficult for Flatpak to keep pace with cutting-edge AI research and deployment, which fundamentally hinders any sovereign AI initiative that aims to be competitive. So if Flatpak isn't the silver bullet, what does real sovereigntech actually look like? So, if Flatpak isn't the answer for sovereign AI, where should Europe be looking to build its future? This isn't a new problem. The tech industry has been solving high-performance containerization for years. Consider solutions like DistroBox, which Fedora developer Luca Di Maio started in 2021. It allows users to run different Linux distributions in containers, providing a lightweight, high-performance sandbox that can access host hardware, including GPUs, with minimal overhead. The key difference from Flatpak is that DistroBox, or similar tools like Podman from Red Hat, are built with development and server workloads in mind, not isolated desktop apps. They manage dependencies without Flatpak's severe hardware abstraction layer. Even more robust options exist. Docker, or more broadly, OCI-compliant containers, are the industry standard. NVIDIA, for instance, specifically designed its NVIDIA Container Toolkit to integrate seamlessly with Docker, allowing direct GPU pass-through into containers with negligible performance loss. This is how large language models are trained and deployed at scale. You also have tools like Singularity, now known as Obtainer, created by Gregory Kurtzer at Lawrence Berkeley National Laboratory in 2015, specifically for high-performance computing and scientific workloads. It prioritizes direct hardware access and portability across different HPC environments. These alternatives offer less isolation by design, where it hurts AI, GPU access, while still providing sufficient separation for development environments. They're built for the precise kind of flexibility and direct hardware interaction that AI demands, something Flatpak, with its desktop-centric architecture, simply wasn't designed for. This raises a critical question. Is Europe investing in the right infrastructure to truly achieve AI sovereignty? Or is it building a sophisticated cage around its future capabilities? The real question here is, what happens when a well-intentioned €500,000 investment inadvertently points Europe's sovereign AI efforts in the wrong direction? The core trap here is that significant resources are being funneled into making Flatpak AI-ready, a task that's fundamentally at odds with its architecture, as we've discussed. This isn't just about a technical debate. It's about an opportunity cost that could significantly impact Europe's future competitiveness in AI. Imagine this. A project funded by, say, the German Ministry for Economic Affairs and Climate Action, investing hundreds of thousands of euros to build out an AI stack on Flatpak. While admirable in its goal of fostering domestic innovation, every euro spent trying to contort Flatpak into an AI platform is a euro not spent on optimizing solutions like DistroBox or dedicated high-performance computing container tooling. By 2026, we could see European sovereign AI initiatives still struggling with performance bottlenecks and driver complexities, while other nations, leveraging more appropriate container technologies like those favored in major hyperscale cloud environments, race ahead. The ultimate irony is that the very effort to escape reliance on foreign tech giants could inadvertently create a new, internal dependency. Building a bespoke AI stack on a suboptimal packaging system might make European projects technically sovereign, but it would still leave them reliant on the fundamental progress of foreign hardware manufacturers like NVIDIA and AMD, whose latest advancements might remain out of reach due to compatibility issues. It's like buying the most advanced Formula One engine, but trying to run it on a tractor chassis. The raw power is there, but the vehicle simply isn't designed to harness it efficiently. The payoff for staying with us through this explanation is understanding that true sovereignty in AI isn't just about ownership, but about building on foundations that genuinely enable progress, not restrict it. So, what this ultimately means is that the pursuit of sovereign AI isn't just about the intent or the funding. It's critically about the architectural choices we make at a foundational level. When we're talking about securing a competitive edge in artificial intelligence, especially for initiatives like Europe's GAIX, directing significant resources into a solution like Flatpak for high-performance AI is a bit like trying to win a Formula One race with a city bus. The €500,000 investment in Flatpak, while well-intentioned to solve a packaging problem, risks becoming a costly detour if it sidelines the fundamental requirements for real AI performance and hardware integration. The challenge here isn't just technical, it's strategic, demanding a hard look at whether the chosen tools align with the ambitious goals of true AI independence. Have you ever seen a major project misdirect resources into a technology that simply wasn't fit for purpose? What was the biggest lesson learned from that experience? Let me know your thoughts and stories in the comments below. And if you want to keep seeing deep dives like this into the operational realities of tech, business, and AI, make sure you subscribe. If you found this breakdown valuable, you'll definitely want to watch my analysis of why cloud repatriation, despite the hype, is a much harder problem than most people realize.